Hello, this is Minder Chen. In this module, we're going to discuss database management. Database is the workhorse of a modern day information system. Um, any kind of application that you're using today, most likely there's a database at the center of it. If you order a book from Amazon's website, the ordering information will be stored in the database. And Amazon has millions of books, and that information is also stored in a database. And your accounting data, your financial data, inventory data, all of that are stored in a database and used by ERP system, CRM system to manage the resources and keep track of all the business transaction at your enterprise. So I'm Minder Chen, Professor of Management Information System at CSU Channel Island. You can contact me at minder.chen@csu.edu. Let's take a kind of high-level conceptual view in regarding information system and the role of data in an information system. Um, in an enterprise, we have resources, and the data that we have are used to describe resources and help us to manage these resources. For instance, human resources, employee. And so we have employee data, and they are a series of activity that's kind of related to human resource management. For instance, hiring employee, um, employee promotion, and pay the employee. And sometimes employee may retire, may get fired, or let go. Then we may remove the employee's data from our system. The typical operation against the data that we have, we sometimes refer to it as, we call it CRUD. Create, update, delete, and read. Let's just quickly go over the kind of business activity corresponding to the CRUD operation. When you hire an employee, we basically are creating an employee record. When you promote employee, we basically are updating the employee's record in terms of their position, maybe salary. And when we're paying employee, we may need to retrieve employees' data to decide on their salary level and how to pay them on monthly or weekly basis. When we let go an employee, that may involve deleting an employee. Okay. In the CRUD, which stands for create, update, delete, and read, there's a standard SQL language which we're going to explain later in detail. The corresponding SQL command which is used in relational database, is called insert, update, delete, and the reading operation is the SQL statement we use is called select. So there's kind of a dual perspective of information system. There are things you have to do, which you rely on the data to help you to do things. There's also resource that we need to manage, and we need data to kind of represent the resource that we have and support the activity we perform in the enterprise. At the information system level, or an information system or application software applications level, uh, data and the process reflecting the data and activity that we were referring to earlier. And another aspect of an application is actually the user interface, which is how we display data, how we allow the user to take certain actions through click of a mouse or selecting a menu item to get certain things done, which is the process. But the process rely on the data, and data need to um, display to the user to present the status of various things they're managing. So UI, data, and process are the three key elements of any application. Let's look at the database role in modern day information system. Um, First of all, we do have different kinds of business application like accounting, marketing, or e-commerce website. The internal user or external user may actually interact with the application in terms of getting access to the data that we have stored in the database. And managing the data in the database, we rely on database management system. We call it DBMS over here. Okay. And there are situations that advanced user may also use DBMS directly through SQL language, structured query language, okay, without going through the application. But this is definitely for advanced user. Typical user just use the application. There's a database behind it, so they're not even aware of the DBMS or the so-called database. They kind of know that data will be stored somewhere, and the application will be are developed by application programmer using some kind of host language such as Python, Java, Java server page, etc. So this is the kind of the overall environment of a database-driven application environment, and the hardware, the server running the database, we usually refer to as a database server. The person who managed the database on the database server is called DBA, database administrator. And the language that we use to interact with the database either through the application program or the advanced user who use SQL directly. The SQL is the structured query language, which we'll discuss later. This architecture shows the client-server architecture, how the user using an application are interacting with a database server and the data behind it. Application server would gather information from the user in terms of their request, and then will formulate the request as a SQL language, most likely a select statement, and we send that SQL statement to a database server. The database would actually send the SQL statement, process the SQL request, most likely a select statement, to retrieve data from the database. And the retrieved data, the data that's being selected from the database will be returned back to the application program. The result out of the SQL query is called result set, and the client application will be responsible to display the result in certain format to present it to the end user, so the user can interact with in the application to retrieve information or entering data and insert new record to the database. Okay, and connecting the client application and the database server, we need some kind of middleware like open database connection, ODBC, through some kind of stored procedure, remote procedure call, or API call to the database server. And by the way, some of you are familiar with Microsoft Office Suite. There is a Microsoft Access, which is a database, but that's usually considered a desktop database. They're not considered a so-called database server, so they're not very scalable, but for small application, it's a viable choice. Let's look at the basic construct of a database. And here we're using a little bit more theoretical term called relational model. But in reality, a relation is just a table. Okay, we're going to use the table to represent a so-called relation in a so-called relational model. So here we're seeing two tables, a division table and the employee table. The division table, think about it like a department table. So we have like 5 different departments, and a department may have a director over here, and then each division has a division name, like computer science division, accounting divisions, stats division, math division, etc. We also have employee table sitting here that has employee number or employee ID, first name, middle name, last name, middle initial, last name, and the division they belong. Okay, so here for each table we usually have something. PK here means primary key. We have a primary key uniquely identify a record or row in a division. Okay, what that means is if I know a division ID, let's say D020, then we can uniquely identify the record, the row, and then we can retrieve this row and say we know the director of the division is employee 19, and then it's a computer science division. Okay, and we can also find out, for instance, employee number 1 is working for division D020. So if you come back here, we know that's the computer science division over here. Okay. So another term which is very important, let's get it out here, is the FK, which is foreign key. We will explain primary key, foreign key in detail later. But here, what is a foreign key? Foreign key is a column, like dir here in the division table, that is used as a primary key in another table in the employee table. So when you have a column in a table that is used in another table as a primary key in that table, then the column in this current table is called foreign key. So if we follow that definition, division is also a foreign key. Okay, if you think about it. Okay, because division, the div in the employee table, the div is a primary key in the division table. The column name doesn't have to be the same, but as long as the meaning, the data type are the same, then this is a foreign key. Okay, and primary key foreign key pair, such as this one here, is important mechanism for us to build relationship between table. And this is why we call this type of database relational database. However, relational database is so common, so nowadays we typically just say this is a database. Most likely it's a relational database. Okay, we used to have so-called hierarchical database, network database, but now it's the relational database. That's the main operational database supporting online transaction processing system in most of the modern day information systems. So let's go over some of the key terms of a database. First of all, database consists of table. A table is a group of homogeneously defined record. We usually call it row. When we say homogeneously defined record, which means, for instance, like a student table, we have student ID, student name, student address, etc. Okay, each record or row should have the same type of data in each of the column as we would explain later. Okay, so each column have a name and also the data type in are determined. Okay, for instance, like string, integers, currency, data and data type, etc. for different column. Okay. Each record is referred to as row in the relational database. There are a collection of values describing an entity like student, faculty, course, etc., customer. And we have column. Column represent attribute of the entity. We're using the term attribute entity that's more conceptual. If you try to describe, let's say, a customer may have customer ID, customer name, customer address, the zip code, etc. Okay, and so through row and column we can find a specific data point, like a particular customer's name from their name column. Key is a column or columns that can be used to uniquely identify a row in a table. We call it key. And however, there are different type of key. One is called primary key. You may have several columns that all of them can uniquely identify a row in a table, such as student ID and let's say social security number in the student table. So both of them can uniquely identify a student. However, we may decide to choose student ID as a primary key because choosing social security number to identify a student run quite a bit of risk. Okay, and we try to avoid that. So that's what we call primary key. It's a key chosen to identify the row in a table. If a key consists of only one column, it's called simple key. It consists of more than one column, then we call it compound, composite, or concatenate key. A key that is other than the primary key in a table, we call it alternate key, but it's also a unique key, by the way. Okay. Foreign key, as we described earlier, it's a column or column appear in a table that also act as a primary key in another table. Okay, that's foreign key. So the question here, what is the mechanism or trick to implement relationship in a relational model? It is the foreign key or foreign key primary key pair. Let's look at an example which gives you a holistic view of what a database is all about. In this case, we have a database that we use to manage a Coca-Cola bottling plant or company, and just assuming this company will receive customers' ordering their drink, and consists of which, let's assume the picture here is a customer order, okay, and which we may have customers' information, ordering day, and order detail, what customer has ordered, okay, and certainly there's could be more than one order detail or order item, order line, okay, and to manage this ordering system, we need to store relevant data in the database, and we don't store like everything in this order in a big table. In a relational database, we would carefully design it, and eventually we will have several tables. Each table are relatively simple to reflect certain entity, things that we're interested in, and store the information to corresponding to those entity. For instance, customer. Okay, we have customer table about basic customer information, including customer ID, customer name, contact name, the primary contact person of the company, the phone number. Okay, and here I'm using the notation to underline the column or columns that has been used as a primary key. So customer ID is the primary key in this case for the customer table. Customer place order. So we have an order table. Order table, we have primary key order ID, and then we have order day that we the day that the order has been placed. We do need to know who placed the order, so the way we can link back to the customer information to know who is the customer that placed the order, we just need to store customer ID. We just need to have a column customer ID in the order table. We don't need to store the rest of the customer information, like their name, contact name, or phone number. Only customer ID will be sufficient. Okay, this allowed us to avoid any redundancy. Okay, reduce or avoid redundancy is very important in database design in data management. Okay, and we fill the order through distributor. So here we have a distributor ID. Then we know who is the distributor for this particular order. And the we have additional columns such as distribution fee, such as the total that's due. And so that's the order table. There's a line connecting the customer table and the order table. That's the relationship. Technically, in the relational database, you don't see this line visually in your SQL statement, which define the table, define the relationship. However, we do have a tool which allowed us to draw ER diagram. We call this ER diagram or data model to visually see the connection between table. So customer ID is a primary key in the customer table, and then the order table has order ID as a primary key, but the customer ID in the order table is a foreign key. So here we're using this oval shape circle, oval shape to highlight the foreign key. So customer ID in the order table is a foreign key. Distributor ID in the order table is also a foreign key, pointing back to the distributor table where it is used as a primary key. Okay. Let's quickly go over the other two tables. Each order can have multiple order line, and we don't store those order line in the order table itself because we could have multiple table line that we technically call repeating group. We cannot deal with repeating group in a table. Therefore, we need to create another table to store those order line one at a time. For instance, we have order. This order has 3 order line. This order ID has 3 order line. So we have line item 1, 2, 3, and we also know what product they have ordered. The only thing we need to know is the product ID. We don't really need to know the product description, product name, or price, because we actually use this information, which is a foreign key, to go to the product table. We use the product ID in the order line, which is a foreign key, to go to the product table to retrieve relevant information about product. Okay, so then the product table just store basic product information, ID, description, and the price. Okay, so now we have actually a simple database which has 5 tables to manage this order processing system. Let's play out a scenario at conceptual level. Okay, if we just hypothetically, there is a disruption in our production of, let's say, Coca-Cola, which will impact all the existing order from customers. So we want to know who has placed an order on this product. I'll just call it AA for the convenience. So just visually, we can come to this table and find out, okay, we have this order line, another order line here. This two order line has this AA product, okay, and they belong to this two order, okay. This and this. If we follow the order ID, then we can come back and we can link back to the order table. Okay, this is 2, 3, so this is 3. So we find out two order. Okay, the 6.1 and 6.3. This two order ID contain the AA product. Okay, but who placed it? We can come here and find out who are the customer who placed this two order. It's customer 23, it's customer 765. Okay, then we can retrieve the contact name of the company and the phone number and start calling them and just alert them your order on this product will be delayed because of some interruption of the supply chain, etc. Okay. So to summarize, as you can tell, in this database we have table. In each table we have column and row, and each table also has primary key uniquely identify a row based on the primary key's value. Tables in the database typically are related to each other. We call it relationship. And the way we implement the relationship is through primary key and foreign key. So once again, a foreign key is a column in a table that is used in another table as a primary key. Okay. One additional thing, it's a little bit detailed, but just try to point out. As you can tell, in the order line, you find the order ID and order line is the primary key. So this two column, the value of this two column has to be unique for the rows in this table. Okay, and order ID, which is part of the primary key, but in this particular case, it is also a foreign key. Okay, it is also a foreign key, pointing back to the order table where the order ID serves as a primary key. So this partial primary key in the order line is also a foreign key. Okay. This is a data model for a popular Northwind database. We have tables, we have line connecting table. In this particular diagram, the notation we use here on the edge of the two line connecting the table, this means one to many, which means each category, product category, may have many products. So we may have a different category. Each category may have several products in a category. So we have one to many relationship. If you look at the relationship here in this Northwind database, they all seems to have one-to-many relationship. Okay, just very briefly, in relational database, at this level, we cannot handle many-to-many relationship. We can handle one-to-one. We can handle one-to-many. Okay, there's a way to represent the many-to-many relationship in a relational database through two one-to-many relationship by adding a table to connect the existing two table. Okay, but that's a very advanced topic beyond this module, so we'll leave it to your database class. So model really means a database. Sometimes we refer to as a schema, which consists of entity of relationship or table and the relationship among table. Relation, the kind of mathematical concept is basically a table. So in a relational model, data are logically presented in a two-dimensional table made of rows, sometimes called tuple, record, or column, sometimes referred to as attribute, field, or data item. This is important for a table in a database. We don't have duplicate row. Okay, each row together has to be unique. There's no duplication. Okay, the order of row in a table is insignificant. Okay, which means we don't really care how data in a table are ordered in a table. The reason is that when we retrieve the data out of the table, we can sort it through our SQL statement. Therefore, we don't really care about the physical ordering of the row in a table. Same thing for column, because when we want to see some data from a table, we just say, I want this column, that column. We don't really need to know whether that's the first column, second column, or third column. As long as we know the column name, we can retrieve its data. So the ordering of the column in a table is insignificant. All attribute or cell, if I may use the term, in a relational database table should be atomic. Atomic means should have just a single value. Okay, so you store like the price, the quantity, which should have a single value. Okay, you cannot store like a multiple price associated with a product record. And each row must be uniquely identified by a primary key. If you know the value of a primary key, you can uniquely identify the row corresponding to that primary key's value. A little bit more advanced, so we're going to just quickly mention it. There's something called index. You can choose certain column in your database table as an index. Index speed up the information retrieval. Primary key column is automatically indexed. But if your certain column, like a foreign key, has may be used frequently in data retrieval, we may certainly create index over it. If certain column's value of certain row is unknown, we call it's a null value. Okay, and when you do data retrieval or do some kind of aggregation over database table, no value has to be handled carefully. View is another term that we need to understand just a little bit. When you query the database, you write a SQL select statement, and they will return a subset of the data from the database in a table or among several tables. You retrieve the data, and you can use that information to whatever purpose you intended to use the data in the first place. However, you're not storing the view physically. Every time you want to use the data, you just run the SQL statement, and the result set retrieved by the same SQL statement may be different because the underlying data in the database may have changed. This is why we may not want to store the data itself. However, if a SQL statement has been used frequently, we want to save the SQL statement as a view so we can use the view to retrieve the data instead of call up the SQL statement through external SQL script file. This gives us some convenience. And also, if we define the view based on a SQL select statement, we could almost use the view as a virtual table, as a table which we refer to as a virtual table in some query. I mentioned a few terms without describe it carefully, such as select statement. This is one of the SQL language. We call it SQL's data manipulation language. Select is one of the most important one for most of the user if they ever want to use SQL language to retrieve data. Select is your friend. Okay. Let's say we have an employee table which has several columns: employee ID, name, department, salary, and hire day. So we have a select statement indicating we're retrieving data from this table. And let's first do the so-called row filtering. It is called horizontal slicing, but row filtering make more sense, which means we only want employee from the engineering department. Okay. In this case, we have 3 rows, 3 employees who are from the engineering department. In SQL select statement, we use where clause. Okay, we use the so-called where clause to specify the search condition, the filtering criteria. So we only retrieve employee whose department is engineering. Okay, that's horizontal slicing. Okay. Now, if we go to the front, we're seeing select clause. The select clause, we're selecting columns that we want to retrieve. Here we say select, we want name, we want salary. So we don't need to return all the column. We can just select the column we wanted. So this is called vertical slicing or column selection. And so the end result is a subset of the original employee table, which only contain 2 columns, name and salary. and also 3 row instead of 5 row. So it is a subset of the original table. In this case, this is called result set. It looks like a table. Therefore, if we store the select statement as a view, it is a virtual table. Virtual table means we're not physically storing the result of the SQL statement. We're just storing the definition of the SQL statement every time we want to look at the data defined by the SQL statement as a view. We just run it. Okay. And the system would dynamically go back to the base table, okay, to run the SQL and to retrieve the information according to the definition of the SQL statement. And if we want to see the result in the sequence of, let's say, by the employee's name alphabetically, we can say sort by name. Order by name, by the way, in SQL, the sorting is called order by. We can just add to the SQL statement and say order by name. If we want to see the result based on the salary from high to low, we can say order by salary, and in descending order. DESC, in descending order. And this is why earlier we're saying that the ordering of the row in the original table doesn't matter. Also, the position, the physical position of the column in the table is not important, because we use column name to retrieve the column that we wanted. So as long as you know the column name, you can show salary before the name. You just say select salary, comma, name, and from employee table, etc. Okay, let's speed up just a little bit. So we have seen the basic database object. The most fundamental one is table. We can retrieve data from table and call query. Query, which is particular select statement, can be stored as a view. Okay, and when we query the database and particular data retrieval, we can actually write the select statement by retrieving data from table, a single table, multiple table, or technically from even a view. Okay, and when we retrieve data from the database, we use select statement. When you need to add new row, update existing row, or delete an existing row, we use SQL's insert, update, delete statement. And select, insert, update, delete together, it's called data manipulation language. Okay. And here I'm kind of used Microsoft Access database object. In Access, they do have something called form and report, and together you can actually build a simple small database application. For large-scale application built on top of database, form, just in the generic sense, form is just could be a web page or web forms. It could be that allow you to enter data which can be captured by your application program, translate that into some SQL statement, and then send it to the database. And that's kind of what the form is about for data entry and for manipulating data in the database. Form certainly can be online form displaying information back to the user. Report, we used to have something called report writer. We retrieve data, we format it nicely, and a lot of time we may even print it out, and that's what we refer to as report. And together, input and output, getting data from the database, form an application based on a database. This is a nice diagram, complicated one. Don't get scared. You will learn this in your database class in detail. As an end user who may use SQL statement to interact with database, most likely you're going to use the so-called select statement. Okay, we're not going to explain the various component or clauses in the SQL select statement, but we have seen like select certain column from one or more table based on certain criteria. And we can also sort the result using order by. Okay, and there's two more clauses called group by and having. We will cover that just a little bit. Okay, it's much more advanced. To keep the data up to date, we need insert, update, and delete. And together with select, we usually call it data manipulation language. In this diagram, they call it data query language. They call select data query language. Okay. Another set of command is called data definition language, which allowed us to create database, create table, drop, we usually call it drop a database, drop a table. We can also update, changing a table, rename a column in a table, etc. Okay, that's called data definition language. Let's look at select statement more carefully. You have seen one before. This is the syntax. You select a list of columns separated by comma from conceptually. Okay, you say, okay, I want to see those information. So you're thinking about the column that you need. Then you have to say, where can I get that information? It may be in one table or multiple table. Okay. And after that, you say, I don't want to see, you may not want to see all the row in a table. You may want to see a subset of it, horizontal slicing. Okay, this is where you will use the filtering criteria, the search condition, the where clause. And after that, you can say, I want the result to be sorted in the way that I want to see it. Sorted by salary, sorted by price, in ascending or descending order. A little bit advanced, you can actually limit the number of rows to be returned. Okay. In Access, as an example, they have a really nice query design tool. You can just select a table visually, and you can drag the column that you want to that you would use or you want it to be displayed. If you want to select column to be displayed, you have to check this checkbox here under show, and you can set the criteria in terms of what's the where criteria, and you can determine the sorting order. So eventually, visually, if you use the query design tool in Access, you can pretty much define the SQL select statement without writing the SQL code, and you may not need to know the syntax in detail. However, if you really want to be kind of database professional or advanced user, I strongly encourage you to learn the SQL and SQL statement, and particularly SQL select statement. Okay. Once again, still in Access, if you need data from more than one table, you will select the table and then remember the database model, the ER diagram that I showed you earlier, the Northwind database, and you can connect the primary key here in the student table with the student number, okay, in the course registration table. There's a one-to-many relationship. Then we can just retrieve whatever the information we wanted. We can also use, this is a little bit more advanced, we can use an aggregate function, okay, and we can group the result by the student number and student name. And the third column is an aggregate function which we're calculating students' grade to 2 decimal place. Okay, their average grade, okay, from more than one course. Okay. Technically, in terms of combining data from the student table and registration table, we're using the common field, the common key. In this case, we're using the student number in the student table and the student number in the registration table. They have to be the same for the data in the two tables to be combined. This is a foreign key. This is where that foreign key is used as a primary key. Okay. And this is the syntax in the SQL statement. It's not critical for this course, but just try to show you a little bit. Okay. Let me use a little bit simpler example to explain aggregation or aggregate function and grouping. Okay. Group by in SQL select statement is a way for us to see summarized data. Okay, in the typical transactional transactional processing systems database, the data in the table are very detailed, may have too many records. Retrieve all of them doesn't make sense. A lot of times you want to kind of group them by certain columns so you can see a kind of an aggregated summary data. Okay, so here we have a simple table which is about a city. City has a city ID, okay, and city's name, the country ID, country it belongs, its reside, and per diem, this is for business travel. We have something called per diem, like your daily allowances, okay. So this is just a simple table, and let's see what we can do with it. Okay. First of all, we can have a create statement to create the table. We haven't discussed this, just a little bit detailed, but it's not that difficult to understand. We are creating a table called city, okay, and then which has several columns like city's ID, name, the country ID, and per diem. Okay, And here we're saying the ID is the primary key, and name can be 100 character long, which is a string, and cannot be null. Not null, it just means you have to tell me the name of the city when you create a new row in the city table. Country ID is not null, and per diem is decimal number with 2 decimal place. The insert, remember insert updatedly. This is the insert SQL statement. We insert into city, and we have all the column listed here, and we say values. Then each tuple, or each technically we call it tuple, represent a row, a new row to be inserted into the city table. So once you create a table, insert those data, this is the table you're going to see. Okay. In this example, we try to show that aggregation. Okay, so we want to, if you look at this select statement, we select country ID. Okay, and we have a count. That's the count is an aggregate function. Okay, we define an alias. Okay, this should be changed to city count. Okay, and we just need to put it in a string and call city count here. And this is a little bit older version. And this format average per diem 2 decimal place, which allowed us to calculate the average per diem for various city in this country and give us that result. Okay, so we have this group by clause, which we group by the country ID. Okay, then we find out that in the first country we have 3 city. The average per diem is $233 or so, because different city has different per diem, so we're calculating the average per diem for city in each country. Okay, and we also want to know how many city that in our table, in our city table that we have for each country. Okay, so this is what group by is about. Okay, you can group by certain columns. In particular, you will use aggregate function, sum, ABG average, count, record count or row count, to give you summarized information. Let's add another table. Here, I added a country table. This is the create statement. You can stop the video and study the SQL statement. It's not that difficult to read. Okay, SQL, the way SQL was designed, it meant to be relatively easy to learn and to use. Okay, and so this is the create table statement to create the country table, and then we actually use an insert statement to insert 3 countries information: France, Germany, and Poland. Okay, and also its GDP. Okay, now we have 2 tables. So what can we do with this 2 tables? We can improve a little bit of our previous select statement. Okay. In earlier statement, we have country ID, we have city count, we have per diem average, and but who knows what country 1, 2, 4 mean? Okay. Now we have this table describe the country name and the GDP of a country based on its country ID. So we can now query the database and get a much more meaningful summarized query by combining data in the city table on the left and then the country table on the right. We will use a joint operation to join these two tables, city and country. And the way we join these two is actually matching the primary key and foreign key. This is the primary key country ID of the country table, and the country ID here in the city table. Okay, you join this two matching column, primary key, foreign key pair, and now I can retrieve country name from the country table. So our result set, it's much easier to understand and to know which country are we talking about. Okay, I think that's we're almost done. Just very quickly, a lot of you are familiar with Excel. When you look at database table, you say, well, I can do that in Excel. And sometimes in Excel, you can use table lookup, V lookup, and X lookup, etc., to combine data from sometimes two worksheet. Okay. However, it's not as flexible, powerful, convenient as a relational database. So when should you use Excel, and when Excel may reaching its limit, and then you're talking about a database solution? Here I list some criteria to help us to kind of decide which solution may be something you want to consider. First of all, if your application required multi-user concurrent access to your data, okay, online reservation system is a very typical application. Then you're talking about database, not Excel. Okay, Excel tends to be designed to be used by a single user, and only one user can get access to that Excel file at a time. Volume of the data. Database high or huge. Excel are getting better. Spreadsheet, like Google Sheet, okay, it's also here. I'm just using Excel, but spreadsheet, kind of low to medium. Okay, they can handle relatively large data, but not too large. And when you have large data, the performance will slow down. So although you maybe still be able to handle it, but it's not as effective. Definitely we can handle complex relationship among data stored in table. Excel, not really. Okay, very, very limited. Calculating kind of information among various data items. Okay, complicated formula. Database, although we have shown you aggregate function, but it's very simple. It's like sum, average, AVG, and count. So it's very limited. Okay, it's like very limited. Excel has a lot of financial function that you can use, and so it's very powerful in this regard. Okay. A business graph, relational database, don't do business graph. You have to export the data and use a third-party tool to do the business graph. Excel, there's a built-in charting tool for data visualization, so they're pretty good. At least for basic one, they're capable of doing it. Application development tool, database don't usually come with application development tool. Excel certainly does not come with application development tool. Although certainly you can build Excel spreadsheet using some macro and hand it to some end user to use it. To summarize, I have just a few more slides left. Key takeaway: database store, organize, and manage data efficiently. It's a workhorse of a modern day information system, as I mentioned at the beginning of this module. Database management system, DBMS, enable interaction with data using SQL, structured query language. Schema, sometimes we use the term schema. It's sometimes interchangeable with the term called database. Database consists of tables, and also we can build relationship among tables within your database. Okay. Application programmer can use SQL within host language to build a database data-driven or database-driven application. Data has to be managed securely, consistently, and with minimal redundancy. Okay, you try to avoid redundancy. And by the way, foreign key, which is a column of the corresponding to primary key that you store in a table, is not considered redundant. Why it matter? Why database matter? Because it enabled data-driven decision making. It powered modern application, support data analytic, and business operation. It is foundation of big data, and big data is one of the key drivers for recent rise of artificial intelligence. And also data nowadays tends to be stored over the network in the cloud through cloud-based services such Azure from Microsoft, AWS from Amazon, and Google has Google Cloud. You may wonder why business professionals should learn SQL. Okay, and certainly you can argue they don't. Okay, it will support data-driven decision making. SQL allow you to directly query and analyze data from business system. Because a lot of time, if you ask the IT department to help you to retrieve the data, they're so busy they may not attend to your request in a timely manner. Okay, so know how to do it as long as you have access to a database and you can do it. Okay, so you can run your own sales trend query from CRM, ERP system, and also know relational database concept and know SQL statement to a certain extent allow you to communicate with data engineer, IT professional, data analyst, and programmer. Okay, and also know the structure of your database and what data you have stored and captured allow you to define the key performance indicator much more clearly and reasonably. Okay, and this also allow you to write smarter data requests and so you can skip the intermediacy, the middleman, so you can just write your own SQL statement directly. It gives you a competitive advantage. So the employee who are hiring business professional, if you have a SQL skill on your belt, it's a plus. Okay, sometimes it's a big plus, depends on the type of job. Okay, because SQL is frequently listed in the job description for product manager, consultant, analyst, and operational leader. Okay, and SQL is the foundation for the use of some advanced tool because they borrow the SQL concept, and like Tableau, Power BI, or Excel's Power Query all use some of the SQL terminology and concept in their system. Okay. For generative AI tool, we often rely on also structured data, which SQL have access to it. So SQL is a standard. It's a standard which work on various DBMS systems like Oracle's database, PostgreSQL, MySQL, which is the one that I've been using lately, and Microsoft SQL Server. Okay, and SQL relational database is used by various functional area like a finance department, marketing department, supply chain, HR. They all use relational database. So in conclusion, okay, SQL is not just a SQL or relational database is not just a technical skill. It is a modern business skill. Okay, acquiring database know-how and SQL skill enhance a business professional's ability to access data directly and allow you to analyze the data and contribute to a data-driven strategy and decision making. So that's all. This kind of give you an overview of database management and why it is important and some of the technical aspect of it. You will have a database course, and then you will learn in much greater detail how to create database, how to design database, how to write SQL statement. So that's all. Thank you. Bye bye.